ProgressiVis is a new programming language and environment for programming progressive visualizations and scalable visual analytics systems. ProgressiVis programs compute and visualize their result progressively. Analysts see initial approximate results quickly and improvements over time. They can even interact during the computation. The benefits of ProgressiVis are scalability for visualization, scalability for interactive analysis, instant data, greener computing, since computation can be stopped if the analysts have their answer before all the processing is done, and algorithmic transparency, the analysts can see the visualization unfolding with the computation. Let's see a few examples. First, using the textual version of ProgressiVis, then the UIE-based version, both running in JupyterLab notebooks. ProgressiVis is a data flow language. A program is composed of modules connected to form a directed acyclic graph. This simple program loads a large remote file containing all the yellow taxi trips in New York City in January 2015, about 15 million, and visualizes the pickup location as a heat map. The program is composed of 5 connected modules, a CSV loader, min-max, histogram, and a heat map that are connected here. When the program starts, the heat map appears after a few seconds and gets sharper over time. Even with a total loading time of about 2 minutes, the analyst sees the visualization immediately. Using the equivalent Python pandas program, it would take about 2 minutes to see the heat map. Making this program interactive requires adding a few more modules. Here an index, a range query, and 2 variables. Once the program is done, running it will show quickly the image, but will also add 2 regular sliders. It can be used to pan and zoom the actual visualization. We saw the basic programming interface of ProgressiVis. The UI-based interface allows building progressive programs interactively. For example, there is a popular story pretending that the number of taxis decreases on rainy days in New York City. Let's see if there is a correlation between the number of taxis and the amount of rain. So, this program loads the rain dataset from New York City, the taxi dataset, aggregate the taxi dataset by day and joins it with the rain, and visualize the result as a scatterplot. Do we see any correlation between rain and number of trips? Yes, there is a clear correlation between them here. So this story, popular story, is actually wrong. We can see the structure of the data flow or the program here, where the 2 datasets are loaded. Then there is a group by here for the taxis, an aggregate for counting the number of taxis per day. The 2 are joined based on the date, and then the scatterplot is created on the bottom using JGalite. Finally, ProgressiVis can also perform machine learning and apply machine learning algorithms progressively. So let's apply a k-means clustering to the taxi dataset while it's being loaded. First, we download the CSV file specifying which column we want, latitude and longitude. Then we launch the downloading, which is progressive, and then we start the k-means clustering. On the 2 latitude and longitudes. As you can see here, after a few seconds, the k-means clustering is visible. It has successfully found 5 clusters one over each airport and one on Manhattan. We can even try to interact by dragging one of the clusters to see if it's well placed or if it's a local minimum. Here it's going back to place, so it was well placed. And under the visualization, we see the quality visualization